Basic Education Certificate Examination BECE 2024. These are the questions that dropped. BECE 2024 Mathematics Paper 2. It is my hope that given all your preparations, you'll be able to solve all. If not all, you'll be able to get a pass mark. Let's see how we can solve these questions. So this is the first question here. So the first question is talking about a fair die and a fair coin. A fair die and a fair coin are thrown together once. Write down the set of all possible outcomes. Find the probability of obtaining a prime number and a tail. So the possible outcome will be this: a head and 1, a head and 2, a head and 3, a head and 5, up to a head and 6. Then we could also get a tail and 1, a tail on the coin and 1 on the die until we got a tail and a 6 on the die. So these are the possible outcomes. So this is the set of all the possible outcomes. Then we have to find the probability of obtaining a prime number and a tail. So a prime number and a tail. So 2, 3, 5 and a tail. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So probability of prime and a tail will be 3 over 12, and that will simplify to 1 over 4. I believe you'll get it. You'll be able to solve this. Let's look at the B part of question 1. The map of a field is drawn to a scale of 1:100. If the width and area of the field on the map are 8 centimeters and 88 centimeters square respectively, find in meters squared the area of the actual field. So you have to do a lot of conversions here. So first, we have 1 centimeter to 100 centimeters. That is the scale. So dealing with area, we have to square. So when we square the 1 centimeter square, we get 1 squared and 100 centimeters square. So we are squaring because we are dealing with area. So 88 centimeters square will be equal to 88 times 100 square centimeters square. And that will give us 88 times 100 times 100. And that will give us 88,000 centimeters squared. So we have to convert this to meters squared. So divide by 10,000. And that will give us 88 meters squared. 88 meters squared. Great. I believe you'll be able to do this one too as well. Then the C part of question 1 is a magic square. We have to copy and complete the 3 by 3 magic square such that the sum of the numbers in each column, row, and diagonal is equal to 21. So we have the first number here for us to find. We can begin with this one. So when we add in this, when we add in this row, we are supposed to get 21. So A will be equal to 21 minus 13. A should be equal to 8. So we spot another one again. We have this column. So we spot this one. Okay, let's deal with the diagonal first. Then we come there. So with the diagonal, we have to add this, and that, and we are supposed to get 21. So let's go. So 21 minus 15 will be equal to 6. Great. So let's spot another one. So we are spotting here. So we can get this column complete. So when we add everything in this column, it should give us 21. And that will give us 21 minus 16, which is equal to 5. We are left with 3 more to go. So let's plot this one here. So this column, everything must add up to 21. So D will be equal to 21 minus 12, which is equal to 9. Then let's plot the next one here. So we are targeting this column here. So this was a row, this is a column. So when we add everything, notice that if you even use a diagonal, you get the same thing. If you use here, you get the same thing. So we are going to get E to be equal to 21 minus 17, and that will give us 4. Finally, we can use this column or this row to get the last entry for the magic square. So we have 21 minus 10, which is 11. So the magic square is complete. Great. So back to our question. So we are complete. We are done with question 1. Now let's deal with question 2. So question 2 is here. Given the vectors p equal m plus 3, 2 minus n, q equal 3m minus 1, n minus 8, and given that vector p is equal to vector q, find the values of m, n, n. So let's do that. Let's do that. So we equate the vectors. So when the vectors are equal, the corresponding components are equal. So the x component will be equal. So we equate the x component, then solve for m by grouping like terms, dividing through by 2, we get m to be 2. We equate the y component, then we group like terms, we divide through by 2, and we get, once again, n to be equal to 5. So we are done with the A part of question 2. So m is 2, and n is 5. So we're told that a man shared an amount of money between his children, Baba and William, in the ratio 6:5. Baba received Ghana cedis 1,200 Ghana cedis. Find the total amount shared. William invested his share in an account at the rate of 20% simple interest per annum for 2 years. Find the total amount in his account at the end of the 2 years. So Baba's share will be equal to 6 over the total ratio, which is 6 plus 5, 11, times the total amount. And in the question, it was given that Baba had 1,200. So we fix it there. Should be equal to this. So we multiply by the reciprocal of 6 over 11, which is 11 over 6. multiply through like that. So we get, remember 6 will go into 1200, 200 times. So 11 times 200 will be 2,200 Ghana cedis. So that is the total amount they had. So that's the total amount they shared. Then we're told that the II, William invested his share in an account. So William's share will be equal to 2,200 minus 1,200, which is equal to 1,000 Ghana cedis. So you could also use ratio to arrive at the same answer. You don't have only one correct method. All right, so William's share is 1,000 Ghana cedis. So this is the principal that William will invest. So remember that the amount in his account at the end of the 2 years will be equal to the principal plus the simple interest. All right, so principal is 1,000 Ghana cedis. So 1,000 times 2 times 20 over 100. 100 will go into 1,000 10 times. So we have 10 times 40, and that will give us 400 Ghana cedis as interest. Then add it to the 1,000 Ghana cedis, and that will be equal to 1,400 Ghana cedis. So that is the amount, the total amount in his account at the end of the 2 years. Great. So we are back to our question. Now should we go to any of them before coming? Okay, let's go in according to other. So we have question number 3 here. Let's solve that one. Or we should solve another one first. Okay, let's solve this one before we go. So let's go to question 3. Good. So question number 3, we have to simplify 3 root 50 plus 2 root 45 minus root 2 plus root 5. So that is the first thing we are going to do. So we recognize that 25 is the same as, we recognize that 50 is the same as 25 times 2. And 45 is the same as 5 times 9. So this is a perfect square, this is a perfect square. So we can break the square root for them so that we will get 3 times 5 here, 2 times 3 here. Then that will give us 15 root 2 plus 6 root 5. So we can add the root 2's, combine the root 2's. So 15 root 2 minus root 2, then we have 6 root 5 plus root 5. So this will give us 14 root 2 plus 7 root 5. So we are done simplifying. I believe you're able to do this one. You'll be able to do this one as well. Great. Now let's consider the B aspect. A wire of length 38 centimeters is bent into the shape of a rectangle whose length is 7 centimeters more than the width. Find the area of the rectangle. So this is the wire. You see that it is being bent into a shape of a rectangle. So the perimeter of this wire is 38 centimeters. Now what do we do next? We're also told that the width is, the length is 7 centimeters more than the width. 7 centimeters more than the width. So if the width is W, the length will be W plus 7. So you know that perimeter is equal to 2 times the width plus 2 times the length. And we're given the perimeter to be 38 centimeters in the question. So we have 38 is equal to 2W plus this. The L is W plus 7. So we have to expand here. 2W plus 14. We group like terms. 38 minus 14 will give us 24. 4. We divide through by 4, we get W to be 6 centimeters. So the length will be 6 plus 7, which is 13 centimeters. When you multiply, you find the area to be 78 centimeters squared. Great. Now let's look at this one. If 15% of the length of a rope is for 720 meters, find half of the length of the rope. Half of the length of the rope. So first, 15% of the length of the rope is 720 meters. So 15 over 100 times L should give us 720. We can multiply by the reciprocal of 15 over 100, which will be 100 over 15. So the actual length will be equal to 720 times 100 over 15. And that will give us 48 times 100, because 15 going to 720 48 times. Then we are left with 4,800 meters. So that is the width, the length, the whole length of the rope. Now we have to find half of the length of the rope. So half of it will be 2,400 meters. Good. So we are back. Now let's take question number 4. Let's go there. Question 4. Using a ruler and a pair of compasses only, construct triangle PQR such that angle PQR is equal to 90 degrees. Line segment PQ has a length of 5.5 centimeters. Then we have line segment QR is equal to 8 centimeters. So we can start the construction by drawing QR. So we have QR here. I'm projecting it so that, because we have a 90-degree angle to construct. So let me label the point. This point is Q, and this point is R. Great. So we now stand at Q, then draw a semicircle. You construct a semicircle. Stand at each point here, then draw an arc to intersect above the semicircle. With a ruler, you draw a straight line. Then we measure 5.5 on the ruler. With the compass, stand at Q and measure that, because PQ is supposed to be 5.5. Then you connect. So P will be at this point. So this is point P. Great. So the next thing is to construct a perpendicular of PR from Q. So this is what we do. Then you stand at these two intersections, draw an arc, then draw another arc to intersect. You can now connect Q through that point to meet PR. So we can label that point of intersection where the perpendicular meets PR over here. Label it as M. Great. So we're supposed to measure MR, and we can see that it is 6.5 centimeters. And we also have to measure QM, and we can see that it is 4.5 centimeters. So we have the D. Then the E part of the question says, the E part of the question, it says that we should calculate correct to the nearest whole number the area of triangle QMR. So remember that area of a triangle is half times base times height. So we substitute. The base now will be here. The base now will be here, or it can be here. So if this is the base, then this will be the height. Great, because this is a 90-degree angle over here. It's a 90-degree angle over here. So we have half times 6.5 times 4.5, and that will give us half of 29.25, which is equal to 14.625, and to the nearest whole number is 15 centimeters squared. So let us now continue. Now, before we continue with question number 5, I would like you to share this video for me. Thank you so much. Thank you very, very much for sharing. All right. Now let's tackle question number 5. Great. So question number 5. In the diagram, triangle PQR is an enlargement of triangle PST. Line segment PS is equal to 4 centimeters. The length of line segment QS is 2 centimeters. And line segment QR has a length of 10 centimeters. Find the length of line segment ST. So line segment ST. We use proportion since the triangles are similar. So ST over QR, because these sides are parallel, should be equal to SP over QP. So we substitute QR, SP, and QP to get this. So we multiply through by 10, and we simplify to get 20 over 3, or 6 whole number 2 over 3 centimeters. Then the II said if PQ, line segment PQ, the length of it is equal to PR. So this is equal to this. We have to find the area of triangle PQR. So when we drop a line from P to Q, we can actually calculate the height using Pythagoras theorem, because that line will divide the triangle into 2 equal parts, since this side is equal to this side. So this will be a right angle. There will be a right angle here. So the next thing we are going to do now is use Pythagoras theorem. We know that h squared plus 5 squared will be equal to 6 squared. So we can solve for h to get square root of 11 centimeters. So recall the area of a triangle is half base times height. Now the base is QR and the vertical height is h, which we found to be root 11. So half times 10 is 5 root 11 centimeters squared. That is the area of a triangle in an exact form. Okay, now the B part. The B part. The total area of a school compound is 900 and a half meters squared. The school has administration and classroom block, library, school park, roads, and walkways. The areas of the administration and classroom block, library, and school park are 300 whole number 1 over 4 meters squared, 200 whole number 1 over 2 meters squared, and 120 whole number 1 over 8 meters squared respectively. Find the area covered by the roads and walkways all together. Great. So this is application of mixed fraction and your understanding of addition and subtraction. So the area covered by the road and walkways altogether will be equal to the total area minus the sum of all the areas I mentioned here. So that will give us something like this. So you have two ways to go about this. You can go the hard way and the easy way. That is how I call it. Or the smart way and the difficult way. So the smart way is that we are going to add the whole numbers here. So the whole numbers, you add this and this and that, 300 plus 200 plus 120, you are going to get 620. Then you should be smart here. You can subtract the 620 from the 900 and be smart and know that half minus half will give you 0. So the half is gone. 900 minus 620 will give us 280. We are left with this small fraction to deal with. That is why I call it a smart way, because you don't have to crack your head with huge numbers. So here we can simply simplify this. LCM is 8, blah blah blah, then you are done. But there's a negative value here, so we can still borrow 1 from the 280. Then we know 280 is 279 plus 1, so to make this positive, so that will give us the LCM is 8, so 8 minus 3 over 8, that will give us 279 plus 5 over 8, and this is the same as 279 whole number 5 over 8 meters squared. So this is a smart way because you don't have to crack your head that much dividing huge numbers, trying to find how many times one will go into the other one. Okay, so now let's look at the difficult way. So the difficult way is that you first of all convert the mixed numbers here into improper fraction. So 4 times 300, that will give us 1200 plus 1. Then 2 times 200 will give you 400 plus 1, 401. Then 8 times 120, then will give you 961. Then 2 times 900 give you 1800 plus 1. So now you have to find the LCM here. Wow, the LCM is 8. So you can imagine these huge numbers, but you can still work it. So you see, 4 will go into 8. 2 times 1201 will give you 2402. Then 2 will go into 8. 4 times 400 will give you 1604. Like that. Then by your bit relief here, because you are adding, subtracting, but you still get huge numbers to deal with. Wow, 2237 over 8. Then this will give you 279 whole number 5 over 8 meters squared. Great. That's just by the way. Anyway you do it, you get the same result and you get the same mark. Great. But just that maybe your time and your head may go against you. So let's go to the final question of this paper. Finally, we have question number 6. Should we go there? Well, if you want us to go there, please share this video, subscribe. Thank you very much for doing that. I appreciate all your support. So question number 6. Let's go there. Question number 6 is here. Great. You are to copy and complete the table for the relation F equal 9 over 5C plus 32, where F and C are degrees Fahrenheit and degrees Celsius, respectively. Using a scale of 2 centimeters to 10 units on the vertical axis and 2 centimeters to 5 units on the horizontal axis, draw a linear graph for the relation. Use the graph to find the temperature in degrees Celsius when F equals 55 degrees. Interpret the slope of the relation. So let's go step by step. The first one, we are going to complete the table. So recall the relation F equals 9 over 5C plus 32. So when X, in this case C, when C is equal to 5, so when C is equal to 5, F will be equal to 9 over 5 times 5 plus 32, and that will give us 9 plus 32, which is 41. So you fix the 41 right here. Then you work again and fix the values there, like that, like that, like that. So we have the table complete. So we are done with the A part of the question. Now let's tackle the B part of the question. So you have the this thing, as you can see here, the graph. This is the horizontal axis where we have the Celsius. Then we have the Fahrenheit on the vertical axis, and the scale that was given 2 centimeters to 10 units. We have that one too on the vertical axis and 2 centimeters to 5 units on the horizontal axis. I believe this did not confuse you because usually they bring the horizontal one first before the vertical one, but this time they brought the horizontal one last. I believe you didn't mess up. Great. So we have to use the graph to find. So we are done with that. So what do we do next? We are going to plot the points. We plot 0 and 32. 0 and 32. So that will be, remember that each of the boxes here will be 1 unit because the interval is 10, 10, 10. So we have 10 smaller boxes. 10 over 10 is 1. So each of the boxes is 1. So 32, you count 2 boxes. So you are here. Then we have 5 and 41. So you are here. Locate 41. This is 40. So count 1 box on top of 40. Then we have 50. So 50 is just right here for you. Then we have what else? 59. So 59, you count 1 box below 60. Then we have 68. So where is 68? So this is 68, 2 box below 70. Then we have 77. So 3 box below 80. Then we have 86. So 6 boxes above 80. So here we have the points, and you can draw your straight line neatly like that. Good job. Good job. So what do we do next? We come to the C part. Use the graph to find the temperature in degrees Celsius when F equals 55 degrees. So we come here, 55 is here. 5 boxes above 50. So we trace to the graph and trace downward. You can see that here each of the boxes is 0.5 because the interval is 5, 5, 5, and we have 10 boxes, so 5 over 10 will give you 0.5. You can see that this is above, it is beyond half of it, so half of this will be 12.5. Then in the middle of the box, so that will be, let's say, half of 0.5, which is 0.25. So add it to the 12.5 and that will give you 12.75, approximately 12.8 degrees. All right, so we are asked to interpret the slope of the relation. The slope of the relation. So the slope is telling you the rate of change. So when this one change 1 unit, this one will change 4 over 5 units. Is it 4 over 5? 9 over 5 degrees. So when this one change 1 degree, this one will change for 9 over 5 degree. So that is the interpretation. All right. Thank you so much. Thank you so much. Expect paper 1 very soon. Don't forget to subscribe. You'll be notified when the paper 1 is uploaded.